Hi, I'm Dr. Topher Anderson. We're here at the ZSK Research and Training Center in Seattle, Washington. In this training center and research center, we look at different ways of making different technical embroidery substrates. So what that means is maybe a customer has a product that they want to try to make out of embroidery. We can teach them how to do it, we can give some samples for them and some pointers, and we can see if it's possible. So some of the things that we have available are, on this wall here, we have fine wire stitching, which allows us to stitch very, very fine wires down to 53 micron stainless steel wires, all the way up to Cat5 cables, allowing us to do very, very small and tight wire embroidery for different types of sensors or wire routing or heating. Here we have a roll-to-roll machine where we're looking at manufacturing in that regard. And what this machine does is for car seat heaters or other types, we can take some fabric in on the front on a roll, we can pull that fabric through, automatically embroider it, pull it through the end, and this allows for a very high throughput manufacturing cycle. Here we have some circuit board stitching, which is one of our smart textile stitching techniques, allowing us to stitch different conductive threads directly into the circuit board, holding them down, and allowing for a large variety of different sensor outputs. In this one, we do work with carbon fiber to be able to do composites work. Here we have a bike seat, but there's a lot of other different composite parts that we can start to look at, manufacturing of, whether it's automotive or aerospace or some kind of sports wear equipment. As well as in the final picture, we have different leather embroidery or smart leathers, where we can start to put electronics in different types of materials, plastics or foams or leathers, in order to start to functionalize those. So right now here, we're in our training room where we teach software training. The software training that we teach is called EPC Win, which is developed by ZSK in order to add the most amount of advantage of our machines and the manufacturing cycles. This allows different features like hot air cutting, beading devices. It allows features like cording devices or wire laying. All of that is taught in this room. So here in this facility, we can teach between 1 to 6 people per training as a small session, and that can be beginners training to kind of get used to the software, intermediate training where you're trying to get some more techniques, and then we also have advanced training packages along the way to help support our customers with the newest technical equivalents, whether that is a new device that comes out from us or some other new development that we figure out here in-house. This way our customers are well supported throughout the process and also given new brainstorming opportunities. Again, here we can do 1 through 6 people. Usually we recommend around 3 people per training session, and we can kind of customize that training based on your request. If you want to look at a very specific thing in smart textiles, no problem, we can try that. If you want to try to make a project with us and have us as kind of a coach back and forth, no problem with that either. Or if you just want to have a generalized learning of what's the newest and greatest in composites or smart textiles, we're gladly able to oblige in that regard as well. In this room, we do different types of electronics prototyping. So we have the capability to be able to analyze and build circuits from the ground up, allowing them to be tailored exactly to embroidery specifications. In that regard, we're capable of doing circuit board building using our pick-and-place equipment and components, as well as different analysis, such as oscilloscope testing, soldering, or reflow analysis. In that regard, we're able to start building up different capability and seeing how it interacts with embroidery, as well as correcting some of the problems that we see in that regard as well. In this room, we teach different types of chenille embroidery, moss embroidery, chain stitching, and tubular arm finish construction. This machine here is a chenille machine, which allows us to create a large chenille thread structure, or moss thread embroidery structure. This structure is very interesting for technical applications because it has very, very high amounts of piles, and that allows us a very volumetrically conductive area, especially when used with different conductive threads. From this area, we can start to create very different types of sensors, such as textile electrodes, or we can also do things such as TENS device for electrostimulation of muscles. This type of machine allows that structure from the chenille structure piece, in which we have that thread system. The chenille machine allows 6 different threads at once, so we can change from thread to thread to thread or color to color, allowing us a very large amount of technical possibilities inside of this type of technique. Over here we have a sprint machine. The sprint machines are very interesting because they are tubular arm machines. So that means we can do finished good construction on them. We can do things such as put LEDs in a baseball cap, or put temperature sensors in a finished shirt or sweatshirt. This machine allows us, because it's tubular, to take this flat table off and put a tubular arm on, allowing us to do rotational embroidery as well. This machine right now is currently set up with a cutting device, which allows us to cut around the outside of fabric, allowing our pieces to fall off the machine much faster, also allowing us to do things like technical applique, where we're putting electronics and cutting around the outsides of them. From this perspective, this machine also is configured right now to be able to do flatbed embroidery, so we can work with flat designs as well. This has a very versatile usage, and we can use it to construct many different types of technical goods, sensors, and also embed different functionality into a finished good. In this room, we do our different sampling and development with customers. So in this room, we have two different machines that we'll look at here that allow us a large amount of different embroidery sampling capabilities in order to look at different technical applications. So in this machine here, we have our Racer XL, which is a 24-thread machine. This machine can have 24 different conductive threads or colors, however you want to look at it, allowing a large amount of different types of technical textiles. Now, primarily we use this machine here in the lab for different types of smart textiles and e-textiles explorations. We are capable of doing different conductive thread circuits on the top of the fabric, as well as using the automatic bobbin changer on the bottom to be able to put fresh bobbins in to increase our speed. On this machine, we also have two different attachments. On this side, we have a hot air cutter. Now, one of the things that we don't like so much about doing manual embroidery is the cutting process. It takes time. So what the cutter does, the hot air cutter, allows us to cut automatically using that pantograph CNC frame so that we can cut around the outside. Or we can use that heat to fuse different materials together. Or we can use that heat to solder parts down to an individual circuit board. The hot air cutter opens a lot of different technical possibilities. Additionally, we have a cording device on this side, which allows us to use different types of textile cords and incorporate them down into the embroidered substrate. Now, these cords could be things like thermoplastic cords, thermoplastic urethane, or they could also sometimes be things like covered wires in some applications. This allows us to use this machine to cycle through and test out different types of smart textiles capabilities. Now, over here we have our JGVA machine. In this machine, we have three different heads. And this machine is kind of the ultimate sampling machine that we have here. This allows us to test every technique that we've shown so far and a couple others that I'll explain now. The sampling that this machine can do is also nice because it has a very large bed that we can work on very large sized pieces of fabric, or also swap those frames out to work on very small fabrics. On the left hand side here, we have a traditional F-head embroidery type with, again, a cutting device to cut around on the outside, as well as an LED sequin device. Now, LED sequins are another way that we can really turn the embroidery machine into a textile pick and place by pushing any electronics down, mounted to a sequin carrier, and spreading them out over the fabric's top. This allows us to kind of pick and place whether we want a temperature sensor in one location or an LED in another, allowing us to really work with that surface of the fabric. On the middle head right here, we have a K head like we looked at before for creating chenille and moss embroidery as well as chain stitching. This allows us a very large area to create different chain stitch pieces. In front of that, we actually have a camera system that allows us to check as we go on any of the heads to look at the placement of those stitches. So if I want to stitch into a circuit board, this allows me to localize the circuit board, find the holes, and adapt the embroidery coding to be able to fit the rotation or translation or any of the other geometric preforms that have happened. As well as that, on the end, we have a W head, and a W head allows us to embroider wire down. We can go thin wires, such as 42 gauge copper wire or stainless steel wire, all the way up to thicker wires. We can also do things a bit thicker than that, like USB cords or Cat5 cable. Additionally, you'll see on the top of the machine, we have carbon fiber, which is another material that we do a lot of work with. That is pure carbon fiber with a low sizing factor that allows us to put down preforms and tailor fiber placement preforms. Those preforms go into an epoxy or resin transfer molding to be able to create a different shape out of that holds its place. Now, another possibility is using thermoplastic or commingled materials, which allows us to be able to create composite preform that we can heat stamp, and we have a part that pops out much faster increasing cycle time and reducing cost of the molding. Now, one other thing that we have up there is an auto feed system, and this is the way that we work with larger pieces of material, not the smaller ones. So small wires usually we'll keep on the bottom manual feeding. For larger rolls, we'll keep those on the auto feed, and that allows us to be able to continuously pull different fibers down to be able to allow that embroidery to go for many hours without having any person in the mix. Additionally, underneath the machine, we have an automatic bobbin changer that again puts a new bobbin in every time it runs out. That way the machine has continuous operation. And another exciting bit of this bobbin changer is it's a version 2 bobbin changer, which means it allows us to match threads on the top and the bottom. So for instance, I can have polyester thread matched to polyester on the bottom. Or I can change and have conductive thread on the top and polyester on the bottom, or I can have conductive on the bottom, polyester on the top, or I can have conductive on both. This allows us to do things like flexible circuit construction, where we have a 2-layer circuit board. We have conductive thread on the top, or we have conductive thread on the bottom to make the 2 different layers of the board. And then we can also have vias that go through the fabric by allowing the stitching to be conductive on top and bottom of that location, allowing electricity to pass or current to pass through the top to the bottom of the fabric through whatever that gap material is. Otherwise, in this room, we do different types of trainings on techniques. We do different types of optimizations. We do trainings on the ability to scale for different manufacturing techniques, as well as looking at custom applications from customers, such as different types of materials or also different types of sequin design. So thank you for joining us on our lab tour. We hope you enjoyed getting to see some of the techniques and services that we provide. If you have any questions, feel free to reach out in the email below, or in the upcoming weeks, we're going to try to post some different techniques and sampling projects that you can do at home. So hit subscribe, that way you can kind of get in on the action. Have a good day.